Hi guys, welcome back to my YouTube channel. Today we want to continue from part 2 of our calculus class. So today we want to take a look at products or multiplication rule in calculus. But before that, let's take a look at some rules used in the concept of differentiation. We have the first one to be product rule, quotient rule, chain rule, implicit of a function, exponential function, logarithm function, trigonometric function, inverse of trigonometric function, parametric equation, Jacobian principle, etc. We have hyperbolic function, higher derivatives, Euler's theorem, and many more. But let's start with products or multiplication rule in calculus. The product rule says if y equals u phi, where u and phi are two functions of x, then the y dx equals u dot the phi dx plus phi dot the u dx. So what we are saying is if y equals these two functions, where these two functions are functions of x, so the first derivative of y with respect to u and phi, which are functions of x, will be keep the first derivative, keep the first function and differentiate the second one with respect to x, and then keep the second one, that is phi, differentiate the first one with respect to x. And take note that dy dx can also be written as y prime, which equivalent to u dot phi prime plus phi dot u prime. So therefore, the phi dx equals phi prime, the u over the x equals u prime. So let's take a look at some examples under this. When we have example A to be x squared plus 2 multiplied by 3x plus 5, we have it to be two functions. So we can declare them to be y equals x squared plus 2 multiplied by 3x plus 5. The first one will be u, then the second one will be phi. So from here, let's record that we have this formula to be dy dx to be equals u the phi dx plus phi du dx. From here, let's obtain the phi dx. Our the phi dx, our phi equals 3x plus 5. Differentiate this phi with respect to s equals the phi dx equals 3. Also, we want to obtain the u dx. Our u equals x squared plus 2. So the u dx equals 2x. So let's substitute all these in the general expression above. We have the y dx to be equals u x squared plus 2 Then the phi dx equals 3 plus phi 3x plus 5, then du dx equals 2x. So by opening the brackets, let's use 3 to open the bracket. We have 3 multiplied by x squared will be 3x squared. 3 multiplied by 2 will be 6, plus 2x multiplied by 3x will be 6x squared. This multiplied by this will be 6x squared. 2x multiplied by 5 will be 10x. So we have 3x squared plus 6x squared will be 9s squared plus 10x plus 6. So therefore, the y over the x equals 9x squared plus 10x plus 6. So let's take a look at another example under this example B. When we have 6x minus 2 multiplied by x squared minus 4, let's declare them to be y equals 6x minus 2, x squared minus 4. Let's take our u to be equals 6x minus 2, then phi to be equals x squared minus 4. Now by differentiating function u with respect to x, we have the u dx equals 6, because the differential of 6x will be 6. By differentiating function phi with respect to x, we have it to be 2x. X squared, the first derivative of x squared will be 2x. So let's substitute all this by recall from dy dx equals u the phi dx plus phi du dx so we have dy dx, our u equals 6x minus 2 our phi equals the phi dx equals 2x plus our phi equals x squared minus 4 du dx equals 6. So let's use 2x to open the bracket. We have 2x multiplied by 6x will be 12x. This multiplied by this will be minus 4x. Plus 6 multiplied by x squared will be 6x squared. Minus 4 multiplied by 6 will be minus 24. So from here we have 12x squared plus 6x squared will be 18x squared minus 4x minus 24. So therefore our dy over the x equals 18x squared minus 4x minus 24. So let's take a look at example C under this again, under the product rule in calculus. We have C. We have it to be 4x plus multiplied by 3x squared plus 2 by declaring them to be y equals 4x minus 1, 3x squared plus 2. Our u equals this, our phi equals this. So let's obtain the first derivative with respect to x. Du dx will be 4 the phi dx will be 6x. So by so doing, let's substitute everything in general expression of the product rule in calculus. We have the y dx to equals u phi u dot the phi dx plus phi dot the u dx. Our u equals 4x minus 1 multiplied by the phi dx equals 6x. Our phi equals 3x squared plus 2. Our du dx equals 4. So by opening the bracket, what we are going to have will be 6x multiplied by 4x will be 24x squared. Six x multiplied by minus 1 will be minus 6x. Then 4 multiplied by 3x squared will be 12x squared. 4 multiplied by 8 will be plus 8. 12x squared plus 24x squared will be 36x squared minus 6x plus 8. So therefore we can declare our first derivative. We have y dx to be equals this. Note that when you have y to be equals three functions, you have yu phi w, where phi, u, and w are functions of x. So here the y dx will be by keeping the two functions, then differentiate the last one with respect to x, u phi, then it will be du, the w dx. By keeping the u and w, we have u, w differentiates the phi, the x, differentiate phi with respect to x. By also keeping w and phi, differentiates u with respect to x, we have phi w, we have du dx. In a situation whereby you have three functions, let's see example under this. When we have y to be equals x squared plus 3 multiplied by 7x minus 1 multiplied by x squared minus 1. So in this case, we have the first one to be equals u, the second one to be equals phi, the third one to be equals w. In this case, you keep the first two functions, differentiate the last one with respect to x. You will keep the first, the third functions, differentiate the second one with respect to x. Then you will keep the second, the third, then differentiate the first with respect to x. So therefore we have the y. We can declare our u to be equals x squared plus 3. The u dx will be equals 2x. Also we have phi to be equals 7x minus 1. The phi dx equals 7. The ratio of 7x equals 7. So we have w to be equals x squared minus 1. So the w over divide the w dx will be equals to x. Differentiate the function w with respect to x. It will be 2x. Now let's substitute all this in the given expression above. So we have the y, the x equals u phi. Keep these two functions, multiply them. U phi, our u equals x squared plus 3. Our phi equals 7x minus 1. Multiply by the w dx, which equivalent to 2x here, plus u phi. Multiply the function u phi. Our u equals x squared plus 3. Our w equals x squared minus 1. Multiply by the phi, the x. Our the phi dx equals 2x plus phi w. Function phi equals 7x minus 1. Multiply by function w x squared minus 1. 7x minus 1 function w x squared minus 1. The u dx function the u dx equals 2x. So by opening all these brackets, what we are going to have will be the first derivative of this, and it will be dy dx equals, so complete this one. If you are new here, watch this video, don't forget to share, like, comments, and subscribe to our YouTube channel for more mathematics tutorial videos. So complete this, comments, share your opinion, let me know what you're trying to say. So therefore, comments in the comments section below. So we're going to meet in the next video, which will be part 3 of calculus. Bye.